Okay, yes, hi. So I shall go through the paper with you all. Okay, so let's look at the question. So clearly, some of the values here that matters to us is cross-sectional area of 0.0050 meter square, meaning A equal to 0.0050 meter square. What else? You have, distance. Sure, so distance 0.074 meter. Cool. What else do we have? We have, the pressure. P equal to 4.6 times 10 power of 5 Pascal. Cool. Okay, so now they ask you to calculate the average force that's exerted on it. Okay, so see, what do we have? We have pressure. And then let's recall, what formula have we learned that has pressure? P equal to F over A. Pressure is the force over your area. Oh, that's cool. That means in this case you are supposed to find force. So you P equal to F over A. You make F the subject. So PA. So P is 4.6 times 10 power 5 Pascal, which is what the unit is supposed to be. And you have your area, which is 0.0050, which will give you an answer of 2300 Newton. 2300 Newton, 2SF? Yeah, 2SF. Yay! Quite straightforward. Oh, yeah, that's done. Oh, cool. Okay, next one will be, this is a moments question, right? So let's take a look at the moments question. It's all about the moment, yo. Okay, so let's take a look at this moment thingy. So with the use of arrow, we are supposed to draw and label the weight. So what do they tell us about this thing? So if you recall, when it comes to a beam, a plank, or all these things, something that usually is associated with is the word uniform. Or either the plank is light beam. No. Yeah, so in this case, there is a keyword here, uniform wooden plank. Uniform wooden plank means the weight will be acting right in the middle. So we are supposed to label. So this plank is 80 cm. The middle of 80 cm is 40 cm. So therefore, here, downwards, this is your weight. And the distance here would be 40 cm. Cool. That's about it. Oh, they also say label the weight. So did they tell you the weight? They did tell you the weight here, right? Weight of 50 Newton. So W equal to 50 Newton. So I labeled it. Yay! So with that, 4A is done. Oh, so now we're supposed to calculate the moment about the hinge, which is another way of saying that the hinge is the pivot lah. Right? So they ask you to find the moment due to the weight. It means it is just the weight alone, the moment due to the weight. So everything else don't matter, only the moment. Sure. So if you recall, M equal to FD, right? So in this case, M equal to FD. The force is 50 Newton. Careful here. There is a trap. There's trap. Because all this is in your perpendicular distance is in meter. They give cm, so they are trying to trick you. So in this case, it's not 40 cm, it's 40 over 100 meter. And when you do that, you realize you'll get an answer of 20 nm. 20 nm. 2SF. That's it. In fact, you can even go an extra mile and tell me, in this case, is this moment clockwise or anti-clockwise? To realize that it is going to be clockwise because the pivot don't move, your force will move this way. So there is a clockwise effect. Yep. So this is actually in the clockwise direction. Just like how the clock works. Okay, next, we are supposed to find tension. Okay, so let's take a look at this thing. So they were saying that, so we have weight, but now you take this rope. It says what? It says this. A rope is used to hold the plank horizontal and prevent it from falling down. So if you can prevent it from falling down and it's not going up, it's essentially telling you this is essentially what we call it balances the weight. That's why if the weight is not balanced, then the plank will go downwards, isn't it? But now they say, oh, it prevents it from falling down. That means the tension kind of counter the weight. Essentially, that's what they're saying. Alright? But then how do we do this then? Okay, very simple. So, okay, this is referring to a balance situation. Balance moment. And how do you know that it's balanced? Look at the green highlighted segment. It is used to hold it horizontal and prevent it from falling down. So it counterbalances it. Okay, therefore, your moment clockwise would be equal to the moment anti-clockwise. Why? This is the idea of the two forces here essentially counter each other. So the clockwise force we have already calculated earlier on, the 20. The anti-clockwise, so recall m equal to F times d, or rather perpendicular distance. Perpendicular distance. Sure, so the force here is tension. You don't know the force. T is the force. Distance, it's not just any distance, right? It is the perpendicular distance. So in case you start panicking, what am I supposed to know? Then you look at the diagram. Hey, I can see a literal perpendicular distance of 90 degrees. So it's 48 over 100. And you realize that the answer is 41.7, which you leave your final answer is 42. Because 2SF. Yep, that's it. That's how we find this out. Alright, okay, moving on. Oh, now the person says something along the line, oh, should he put his items nearer or further away from the hinge to prevent it from snapping? So let's look at the diagram again. The diagram, what happens is, so you can put items and everything. So we should actually put it nearer to the why? Okay, so when your items are nearer to the hinge, or in other words, basically the pivot. So it's actually playing on your equation. So m equal to F times perpendicular distance. So when it's nearer, this results in the perpendicular distance being lower, isn't it? It's like you push a door about its hinge. You usually push the handle is like furthest away from the, okay, let's say this is the door, then the handle is here. So you usually push the handle here to push the door. If now the handle is nearer to the center, the perpendicular distance is lower. So the perpendicular distance is lower. So what? If the perpendicular distance is lower, this will actually lower or reduce the total clockwise moment. Okay, don't panic. Let's look at the previous part. So if let's say you have an item, let's say let me draw for you. Okay, item. So that is your item. So in this case, the item has the weight downwards. If that is the case, your item would actually rotate clockwise. So that's how you see. So it reduced the clockwise movement. Then, so what if it's reduced? Remember the purpose of the tension in this case is actually to counterbalance the weight, or basically the total clockwise. So if the clockwise is now lower, this means that it will need lower anti-clockwise to balance it all. To balance it. So it's again the word balance. Balance it off. So that there's no net moment. So now you need lower anti-clockwise moment. That means the tension will also be lower. Then recall, tension is the higher the tension in a rope, the more easy it will snap. It's like a rubber band. When you stretch it out, it's very tense. That's why sometimes you can use a rubber band to shoot people, The tension is very high. When the tension is high, there is a higher chance of snapping. So when the tension is lower, it prevents it from snapping, or rather it lowers its chance of snapping. It's like, for example, you are very stressed, right? You are very tense. Anything will just cause you to snap. If let's say you're very chill, then not tense at all. So you don't snap, for example. Yep. So you might be wondering where the 3 marks go. So nearer is 1 mark. And the explanation of this segment. Then the next segment is 1 mark. So that's your 3 marks here. Okay, moving on. So it's a graph question. So let's take a look at the graph question. Graph question. Let's see. This is... Okay, so let's take a look at what is given to you. It says that 180 kg. They give you a value, and the value is likely to be very useful. So take note of the value. It tells you that mass equal to 180 kg. Cool. What else? It says it accelerate blah blah blah. Oh, it accelerate from what? Speed of 40 to maximum speed. Isn't it telling you VI is 40? VF wise, do you know what's the maximum speed? They never say, but look at the graph. What's the maximum speed on the graph? Isn't it just 80? Oh, cool. Yep. Next thing. Oh, what about time? Time. Anyway, never mind. Let's look at A first. For segment A, T is 2 seconds. Because they say one, it's 0 to 2. Acceleration. Remember the formula? A equal to VF minus VI over T. I have the final velocity, initial velocity, T. So okay, again, be careful. In this case, your VF after 2 seconds, let me use another color. 2 seconds, it's here. So from the graph, I can see that it is about 55 about 55. So A equal to 55 minus 40 over 2, which will give you an answer of 7.5 meter per second square. Again, 2SF. Yay. Yep, next. Oh, resultant force. Hey, sounds familiar, right? Remember Fresma? Your resultant force equal to MA? Hey, I got A. Do I have the mass? I have the mass. So it's actually just 7.5 times 180 kg, which gives you an answer of 1350 Newton, which is 1400 Newton. 2SF. Cool. Yep. Okay, so next segment, let's take a look at the next segment. So it says what? Oh, the driving force acting on the motorcycle remain constant. Okay, force is constant. The driving force means the motor. It says it remains constant. So the motor, the force is the same throughout the 12 seconds. So using 10.1, meaning let's look at the graph. So the graph shows you the 12 seconds. But the speed so actually you're accelerating, right? If you're accelerating, shouldn't it be just accelerate and remains the same? But what happened? It eventually hit a maximum speed. So what it's telling you is this. So again, look carefully. It says what? The keyword here is called describe how the acceleration change. Then we were thinking, how I know what's acceleration? So let's look at the graph. Graph says speed and time. So as you recall, gradient is y-axis divided by x-axis, which in this case speed divided by time. If you recall, that equal to acceleration. Oh, so now you are supposed to focus on the gradient. So now this is the gradient. Oh, so for B part 1, you are actually just supposed to describe the gradient lah. So at the start, what happens? At the start, there is what we call constant gradient, which or constant acceleration lah. But it will actually, so it start with constant acceleration. Then after it will gradually decrease. Because why? Your vehicle is slowing down. It hits the maximum speed at the end. It gradually decrease to where? You can see, right? There's a particular time frame here. It is like about, let's see, how many seconds is this? It's about 8.4 second, 8.5 second. Decreases until there is no acceleration, which is from time equal to maybe 8.4 second, 8.5 second, thereabout. Yep, that's it. So that's what it means by describe. You need to use the graph. Every single every single different segment of the graph you describe with numbers. Okay, next. Oh, now you're supposed to explain in terms of forces. Why? So very simple. What happens is this. So you see, question says what? Yellow here. Driving force of the motor same. If the driving force if the motor force is the same, how come the acceleration slower and slower? That means there must be something else. That something else is called air resistance. So as you recall, when speed increase, your air resistance also increase. So what happened here is this. Has the motorcycle accelerate? It is accelerating, isn't it? It will actually experience greater air resistance because it gets faster and faster. Air resistance is linked to speed. The faster you are, the more resistance in the air you feel. So you experience greater air resistance. Air resistance is basically a type of force, isn't it? So this is basically a force. So as you go faster, you have an extra force that you are feeling. That means this one causes the resultant force to decrease. And you recall, isn't it F equal to ma? If your F drop, your acceleration also drop, So this means that the acceleration will decrease. But does it eventually stop? It does. So what else do you write down? You need to write down that when the total resistive force or air resistance equal to the driving force, which is the motor that means these two are equal, means they cancel out. So this results in no resultant force. Stop acceleration. Yep, so these 3 marks is a little bit tough to get. Let me separate the mark weightage for you. So how am I going to get the mark weightage? First and foremost, here, you tell me that it accelerates, it has a faster speed, right? Which means greater air resistance. That's the first segment. Second mark is here. You tell me, after that, there's the resultant force is lower, the acceleration lower. And lastly, this is the last mark. Yep. Okay. So what's next? Okay. There's a satellite here. So let's take a look at the satellite. What's happening here? Okay. Let's take a look. So you have a satellite that's orbiting the Earth. Means it goes in rounds around the Earth. They said even though it is a constant speed, and in a circle, it's accelerating. How come constant speed got acceleration? So if you recall, what is acceleration definition? Acceleration technically is the rate of change of velocity. Right? That is the definition. Velocity. What is given? You are given speed. If there is acceleration, doesn't it tell you that there is a change in the velocity? It means velocity is not the same. So the answer is this. The velocity is not constant. And why is that so? Because the direction of motion is changing, isn't it? Let me draw an arrow to show to you. So that means, let's say at this moment, this is the velocity. The next moment, the velocity is here. Next moment, the velocity is here. It keeps changing, you see. And since acceleration is the rate of change of velocity, acceleration also accelerating. Alright. Okay, next part. This is a definition, giveaway definition. So what is gravitational field strength? You may remember this has G equal to 10 Newton per meter. So this is a definition. It's basically the amount of gravitational force. Per unit mass. Which is again, it is in the formula, you see. Newton, which is force, or rather gravitational force, per m, and meaning per unit the mass. Yep. Oh, now we're supposed to use the graph to determine the gravitational field strength at 800. So where is 800 on this graph? Oh wow, this is not very good for my eyes. 5, 6, 7, 8. 800. 800. Oh my god, my eyes. So it is actually 7.8, 800. So in this case, you're supposed to give me the value. Is it? Yep, you will get 7.8 Newton per kg. Per kg, oops. Yep, so be careful, you may leave out the units, and also do take note it's 2SF. Oh, now at the same height, you're supposed to calculate the weight. Sure. If you recall, the formula here is W equal to mg, right? So m, what's the weight? Let's take a look. Did they tell you? Yes, 84 kg. Sorry, the mass is 84 kg. 84 times 7.8. Equivalent to 655.2, which is 660 N. Remember 2SF? 660. Yay. Yep. Okay, next one is another speed time graph. Wow. Sure, let's take a look. This is question number 9, huh? Sure. So, it says that there's some cycle track here. Okay, sure. Then it follows this speed time graph. Okay. So use the information in both of them to describe. So the keyword here is called describe motion. So that means you need to tell me, so from the graph is a speed graph. So you need to tell me the actual value of the speed. So what happens here is, it goes from rest. Rest is not moving. Rest is basically 0 meter per second to a final speed. So you read the thing, you realize that a final speed of 6 meter per second. Huh? Like that 2 marks, man. Where's the second mark? So as you recall, motion, this kind of motion question, we will expect you to talk about speed with values. Because the graph will give you the value. And we also expect acceleration. No need values for acceleration. But you need to tell me whether it's a constant, increasing, decreasing, those kind of thing. So let's look at the graph. Where is the acceleration in the graph? So gradient, again, recall, gradient is y-axis over x-axis. Which is speed. Which is acceleration. So in this case, I'm looking at the acceleration. So what happened then? You can see that's increasing the straight line. So what happens, we can say that it is actually constant acceleration. Do you need to calculate a value? Don't need. Yeah, that's pretty much about it for this part. Okay, next one. Along BCDEB, which is that straight line segment. Sure, so same thing. Tell me the speed. So the speed here, it is actually constant speed. Constant speed of what? It is given in the graph, isn't it? Read the graph. Constant speed of 6 meter per second. Actually, that's about it. I mean, technically speaking, there is no acceleration lah. Because constant speed, no acceleration. Yeah, that's it. Cool. So they say that a velocity at c is shown. Okay. So now they're saying that c, the velocity at c and the velocity at e, what's the similarity, what's the difference? So the similarity is that they have the same magnitude. Or the speed itself is the same. But the difference will be different direction. And now we're supposed to calculate the circumference. Oh no, math. So let's take a look at the circular part. So how are we supposed to calculate then? Don't panic. Let's take a look. So you want circumference, right? So let's take a look at your graph. AB. So in AB represents this. It's not even and nothing to do with the circle yet. Then next, what you have here is B to C to D to E to B. One whole round, which is what is known as circumference. Oh, isn't that just this segment? Because why? If you recall, area under the curve, area under the line, the curve, is basically y-axis times x-axis, which is speed times time, which is just the distance. So long story cut short, they are just asking you, can you find the area under the curve in this case lah? Which is very simple, right? It's just 6 times 72 minus 20. 310 meter to SF. Cool. And lastly, you're supposed to find the acceleration from point A to point B. Sure. So A equal to VF minus VI over T. You don't have A. Do we have VI? Have 6 or? So 6 is the final. Initially at rest. 6 minus 0 over 20. Is it 20? Let me check again. Yeah, 20 seconds. 20 seconds, right? 20 seconds. It gives you the answer of 0.30 meter per second square. Again, 3SF. Sorry, 2SF. Can? Yep, that's about it. Any questions? Please ask me.